Imagine standing next to a weapon so massive, the barrel alone stretches longer than a football field. Around you, thousands of soldiers, engineers, and workers are building entire railway lines just to move this machine a few kilometers. In 1941, Nazi Germany created this gun believing it would become a war-winning superweapon. It fired shells heavier than a tank, required weeks of preparation for a single shot, and consumed enormous military resources. And yet, after all of that effort, it barely changed the war at all. So why was it built? And what does this impossible machine reveal about how wars are really fought? The weapon was called Schwerer Gustav, and when it was finally completed, it became the largest artillery piece ever built and deployed in combat. The entire system weighed over 1,300 tons, required 2 parallel railway tracks to operate, and needed a support force of nearly 4,000 personnel just to function. But Gustav did not begin as a weapon. It began as a problem. In the late 1930s, Germany faced a defensive barrier many military planners believed was nearly impossible to destroy. Stretching across the French border was the Maginot Line, a vast network of underground fortresses, reinforced artillery bunkers, armored tunnels, and defensive corridors buried beneath layers of reinforced concrete. Some sections were protected by more than 7 meters of steel-reinforced concrete, specifically designed to survive prolonged bombardment. Traditional artillery simply could not penetrate defenses of the scale. Even the heaviest siege weapons of the time lacked the destructive power needed to reach deeply buried targets. German strategists feared that if they were forced into a direct confrontation with these fortifications, they would face a defensive system designed to outlast and outgun conventional warfare. The challenge eventually reached Krupp, one of Germany's most powerful industrial weapons manufacturers. Krupp had built heavy artillery during the First World War, but the new request pushed engineering into territory that had never existed before. Military planners demanded a weapon capable of firing shells powerful enough to penetrate deep underground fortifications and destroy structures that were considered nearly indestructible. Engineers quickly realized that achieving this level of destructive force would require abandoning nearly every traditional limitation of artillery design. The barrel alone needed to stretch more than 30 meters to generate the velocity required for massive projectiles. The recoil system had to absorb forces powerful enough to tear apart conventional gun platforms, and the ammunition itself had to be redesigned into enormous armor-piercing shells weighing nearly 7 tons each. But solving the physics of the weapon only created a new problem: transportation. Gustav was too large to move by road, too heavy for standard railways, too complex to deploy quickly. The only solution was to build specialized railway systems capable of supporting the gun's massive weight. Even then, the weapon could not simply arrive and begin firing. Engineers had to construct curved railway tracks to aim the gun horizontally, and entire firing positions required weeks of preparation before a single shot could be fired. At this point, Gustav was no longer just a military project. It had become something closer to an industrial monument, a demonstration of what happens when technological ambition stops asking whether something should be built and focuses only on proving that it can be built. Thousands of workers were assigned to assembly, maintenance, transportation, security, and ammunition logistics. Entire support units existed solely to keep the weapon operational. Gustav consumed enormous manpower, infrastructure, and time. Resources that, in modern warfare, often determine the outcome of conflicts more than individual weapons ever could. And by the time Gustav was finally ready for combat deployment, the nature of war had already begun to shift. Speed, mobility, and coordination were rapidly replacing static siege warfare. Massive fortifications were becoming less relevant. Armies were learning to move around defenses instead of smashing through them. Gustav had been built to destroy a world that was already disappearing. And when this enormous weapon finally reached the battlefield, it would reveal a truth that engineers, generals, and entire nations often struggle to accept: that scale alone rarely guarantees victory. By early 1942, Schwerer Gustav was finally ready for deployment, but moving the weapon into combat was an operation that resembled a military campaign of its own. The target chosen for Gustav's first major operation was the Soviet fortress city of Sevastopol, located on the Crimean Peninsula. The city was heavily fortified with underground bunkers, reinforced naval batteries, and ammunition depots carved deep into rocky terrain. German commanders believed Sevastopol represented the exact type of defensive stronghold Gustav had been designed to destroy. Transporting the gun required weeks of preparation. The weapon was dismantled into massive components and moved by train across occupied Europe. Once it reached the front, construction teams immediately began preparing the firing site. 2 parallel railway tracks had to be built along a reinforced embankment to support the weapon's enormous recoil forces. Additional curved track sections were installed to allow horizontal aiming, since Gustav could not rotate like traditional artillery. Preparing Gustav for firing was not simply technical, it was logistical theater. Nearly 4,000 personnel were assigned to support the operation, including artillery crews, railway engineers, construction units, security forces, anti-aircraft defenses, and ammunition transport teams. Massive cranes were required to assemble the barrel and load projectiles into place. Each shell weighed close to 7 tons and required specialized rail-mounted loading systems. But what most people don't realize is that Gustav's greatest weakness was not enemy resistance. It was time. Every shot required hours of preparation, alignment, stabilization, and coordination between multiple technical crews. And this delay would soon turn Gustav into one of the most vulnerable superweapons ever deployed. When Gustav finally fired, the effect was extraordinary. The recoil shook the surrounding ground, and the blast could be heard across vast distances. The shells traveled dozens of kilometers before impact, striking fortified Soviet positions with devastating force. Several projectiles penetrated deeply buried ammunition depots, triggering massive secondary explosions that destroyed entire defensive installations. From a purely destructive perspective, Gustav performed exactly as engineers intended. But behind every successful shot was a logistical operation so massive that it sometimes required more soldiers to support the weapon than to fight the battle itself. And when historians later studied Gustav, they discovered something deeply uncomfortable about how modern wars actually consume manpower. If you enjoy exploring the hidden stories behind the most extreme machines in history, consider subscribing. This channel focuses on the inventions that reveal how war, technology, and human ambition often collide in unexpected ways. Despite its power, Gustav could only fire a limited number of rounds per day. Ammunition production demanded enormous industrial resources. The firing position required constant protection from air attack, supported by dedicated anti-aircraft batteries and infantry units. And perhaps most importantly, Gustav was almost completely immobile once deployed. Relocating the weapon required dismantling large sections of its structure and rebuilding railway infrastructure at a new location, a process that could take weeks. On a battlefield that was becoming faster and more mobile, Gustav operated like a static siege monument from an earlier era of warfare. At this stage, Gustav felt less like a weapon designed to win battles, and more like a monument built to demonstrate industrial power. Even during the Siege of Sevastopol, German commanders began to understand that while Gustav could destroy specific targets, it could not influence the broader strategic momentum of the war. Battles were increasingly decided by speed, coordination, armored divisions, and supply networks, factors that massive single-purpose weapons struggled to support. And this is where Gustav's story becomes truly strange. Because despite its enormous destructive capability, the weapon was already becoming obsolete the moment it was first used. Understanding why reveals one of the biggest misconceptions about military strength. By the time Sevastopol eventually fell, Gustav had proven its destructive force. But it had also exposed a deeper truth, that some of the most complex weapons ever built exist less to change wars, and more to justify the enormous resources already spent creating them. Superweapons often promise simple solutions to complex conflicts. History shows they usually create new problems instead. And Gustav's story was far from over. Because as the war continued, the weapon would soon collide with a battlefield where scale alone could no longer keep pace with the speed of modern warfare. After the Siege of Sevastopol, Schwerer Gustav remained operational, but its role in the war was already fading. The battlefield was changing rapidly. Fast-moving armored divisions, coordinated airstrikes, and mobile artillery were beginning to define modern warfare. Massive stationary weapons, like Gustav, struggled to adapt to this new reality. Plans existed to deploy Gustav against other fortified targets, but logistical complexity made repeated use increasingly impractical. Moving the weapon required dismantling large sections of its structure and rebuilding specialized railway infrastructure. Each relocation consumed enormous time, manpower, and resources, all during a war that was accelerating beyond the pace Gustav could follow. A second gun, known as Dora, was also constructed. It was nearly identical to Gustav and represented the continuation of Germany's investment in super-heavy artillery. Yet both weapons faced the same fundamental limitation. They were engineering triumphs built for a type of warfare that was already disappearing. As Allied forces advanced deeper into German territory, Gustav's strategic value declined further. Air superiority made large, slow-moving targets extremely vulnerable. Maintaining and protecting such a massive weapon required defensive resources that Germany could no longer afford. By 1945, as the war approached its final stages, German forces made the decision to destroy Gustav to prevent it from being captured. Sections of the weapon were dismantled, damaged, or abandoned during the chaotic retreat. When Allied troops later discovered the remains, they found not a symbol of unstoppable power, but fragments of an industrial experiment that had outlived its purpose. Gustav had fired only a limited number of rounds during its operational life. It destroyed specific targets, demonstrated extraordinary engineering capability, and left behind one of the most unusual chapters in military history. But it never changed the outcome of the war it had been built to influence. And this is where Gustav becomes more than a weapon. It becomes a reflection of how nations often approach conflict. The belief that building something larger, stronger, or more technologically advanced will automatically deliver victory is deeply rooted in military thinking. Yet Gustav shows how scale can sometimes distract from adaptability, speed, and strategic flexibility, the elements that more often determine success in modern warfare. Gustav was not a failure of engineering. It worked exactly as designed. But it revealed a different kind of failure, the assumption that technological power alone can solve complex human conflicts. History is filled with machines built to change the course of wars. Some succeed, many do not. But the most revealing ones are often the machines that forced entire nations to confront the limits of their own ambitions. Schwerer Gustav remains one of those machines, not because of how many battles it won, but because of what it revealed about the way wars are imagined, funded, and fought. If you're interested in the hidden stories behind extreme inventions, forgotten military projects, and the machines that quietly shaped history, consider subscribing. This channel explores the objects that reveal how technology and human ambition often collide in ways history rarely explains.